one I want to explain to you a rule, and then after that we're going to do examples about that rule. So what if you have a situation where the function is not always positive? So far we've restricted ourselves to situations where the function is positive. So like this function right here, it oscillates. First it's positive, then it's negative, then it's positive again. How do you find the total area between the function and the x-axis? And the answer is pretty simple, actually. You go in bits and pieces. Like first you go from A to B, then you go from B to C and C to D. In each case, you find the integral. You apply the fundamental theorem. But when you are dealing with this side where you have a function below the x-axis, just remember to take the absolute value. So this is the rule. As you can see, from B to C, I took the absolute value of the function because it was below the x-axis. It was negative in that region. So from now on, since we are not restricting ourselves to just positive functions, you guys have to be very careful from now on, okay? When I say find the area between the function and the x-axis, the first thing we must do from now on is we must graph it, because you need to know, is it always positive? Does it go below the x-axis at any time? Second, you must find the x-intercepts. If it goes below the x-axis, you must find all the x-intercepts, and then you integrate over each of those intervals where it's positive and where it's negative. And don't forget at the end to add the absolute value of all the answers. Obviously, the positive ones, you don't have to take absolute value, but the negative ones, you must. Okay, if you guys copied it, then I'm going to go ahead and give you another example then about finding area. Let's find the area between f of x equals x squared minus 2x over the interval from 0 to 5. Find the area between f of x equals x squared minus 2x over the interval from 0 to 5. So the moment from now on you hear the word area, you must graph the function, because we're no longer restricting ourselves to positive functions. You need to know, is it always positive, negative, or somewhere in between? So we must graph this function first. And this one should not be a hard one to graph, because first of all, it's a quadratic function, right? It opens up or down? Up, because x squared is positive. What are the x-intercepts of this function? If you set equal to 0, you get x times x minus 2. 0 and 2 are the x-intercepts. So already we have a pretty good idea about what 0 and 2 are the x-intercepts. So it opens upwards. So roughly speaking, this is what the graph looks like. And we want to find the area from 0 to 5. So let's shade what that region looks like. So it will consist of the union of two separate regions, right? It's going to be the union of this region plus this region. Okay, how will we set it up? Can I go in one shot? I can say integrate from 0 to 5. No, that will give you the wrong answer because you have some negative area there that would take away some of the area from the other one. You would not be getting the correct area. So the way to set this up is, first, say, let's say A sub 1, the first area will be the absolute value of which integral? 0 to, right, the intersection point there is 2. So integrate from 0 to 2 of f of x dx. In other words, x squared minus 2x dx. Basically, whatever the answer turns out to be, at the very end, take the absolute value. Don't take absolute value in the intermediate process, but finish this integration. You're going to get a negative answer, and you must get a negative answer because you see the region is negative, and then make sure you make it into positive. Okay. Then integrate. Find the second area, a sub 2, which will be the integral of, from where to where? 2 to 5 of the function f of x dx, which is x squared minus 2x dx. Once again, same function. And that you expect to get a positive answer. At the end, we're going to add the 2. I'll give you a little bit of time to work on this. But just this notation dx, by the way, it's kind of like symbolic, right? It's really not doing anything. When you take an antiderivative, that dx is really not doing anything, right? But why is it there? It's like symbolic of the, where it's coming from. Remember summation f of x by delta x? The dx is representing the base of the rectangles. But here it's really not doing anything with the shortcut method. It's just there to remind us where everything came from, basically. Okay, I'll give you a little bit of time on this. So once again, we take the antiderivative, of course, plug in the upper limit minus the lower limits. So if I plug in 2, I get 8/3 minus 4. Plug in 0, I get 0. And that's the same as 8/3 minus 12/3. So I'm getting negative 4/3, which is to be expected, right? First, the integral was negative, but the area of that first region is going to be the absolute value of that answer, which is positive 4/3, right? Then let's find the second area. That one was from 2 to 5 of the same function. Again, first I write the antiderivative. And the limits are going to be from 2 to 5. Now, just a little important, I want to point out something with regard to the notation. Many times when I'm grading students' papers, students find the antiderivative, and after they find the antiderivative, they keep their the integration notation there. This would be wrong. This is kind of like saying, you took the square root of 4, you got a 2, but at the end you kept your square sign still there. That's completely incorrect, right? So once you take your antiderivative, you should not have the integral symbol there anymore. Okay, you can put the line there to represent. We're going to evaluate it, but the integral sign has done its job. You found the antiderivative. It should disappear at that next level. Okay, so now let's plug in the upper limit, 5. And then minus the lower limit of 2. And once again, I'm going to combine the fractions first. So that's 1/25 minus 8/3. And then the whole numbers are negative 25. And negative times negative is positive 4. So that's 1/17 minus 21. And again, getting common denominators. I get 117 minus 63 over 3. And for that, I got 54 thirds. So what should be the final answer? Right, I'm going to keep it like that because I know I'm going to be adding it to the other one. So one part was 4 thirds, the other one was 54 thirds. So I'm going to add the two together. So 54 thirds, oops, not 13ths, but thirds, plus 4 thirds is indeed 58 thirds. It's not writing so well. There we go. Okay. So this is the total area enclosed between the graph and the x-axis over the given region. Yes, Daniel?
Now, would you always add the two areas, or would you ever be subtracting it all?
If the question says find the total shaded area, you should take the absolute values of each of the separate areas and you should always be adding them.
So you never have a negative?
If the question uses the word area, now we're going to do some examples where you're going to see, but if the question says area, you should always take absolute value, you should always add. Okay, I'm going to give you one more example about area. And it's on the bottom of this page. Okay. This question, you don't have a specific function. Like, I don't know if it's f of x squared or x cubed, I don't know. All I have is I have a graph. So you can see first it's positive, then it's negative, then it's positive again. And they gave us the integral values over those three regions. From A to B, it's 2. B to C, it's -5. C to D, it's 6. They gave us the integral values. And there are two questions to be answered. One is, what is the total shaded area? And the other one is, what is the total integral? The integral for a positive function, it gives you the area, right? For a negative function, it gives you -1 times the area. So what will it be? What will be the total shaded area? So there you add the absolute values, right? So 2 plus absolute value of -5 plus 6. So you are correct in that regard. So here it should be 2 plus absolute value of -5 plus 6. So that is 13. And then the question says, what is the integral from A to D, from the first point to the last point, of the integral of the function? Now this is not referring to the area at all. It's just saying what's the total integral. And there is actually a property that says, like, if you're going from, let's say, from A to D, you can add up the integral from A to B, to the integral from B to C, to the integral from C to D, and that will give you the integral from A, from the original point to the last point. So that one, guess what that one will be? 2, right there you don't take any absolute values. And that one turns out to be 3. So if the question says area, you should always be adding absolute values. If the question just a practice problem on what is called integration, then you have to keep all the signs as they are, like we did in this case. As a matter of fact, some of the next few examples we're going to be doing, we're going to be practicing integration in general, not just area, because integration has many more applications besides area. So that's what we're going to be doing next. So one more area question, and then we're going to go to something a little bit different. This one is a little bit unusual in that it's not area under the curve, right? This time they are asking the area above the curve. So how do we deal with that? I want to give you some time to think about it, and then we'll go from there. first I want to do some brainstorming. Any thoughts how we could approach this question, how we could find that shaded area? Yes, Sandra? Which is going to be base times height, right? I think that would work perfectly, don't you think? Because if you find the integral of that function from 0 to 1, that gives the area under the curve, right? We can find the total area of the rectangle, subtract it, and you can find the area above the curve, right? By the way, I don't really need to tell you even the height there. And some of the group activity questions, I did not give you the height. How could you have obtained the height if I did not give it to you? If I gave you x equals 1, you would just plug it into the function, right? So 1 squared plus 2 would be 3. That would be your height. Okay, so let's do just that. To find the area above the curve, first we're going to find the area under the curve. So I should go from 0 to 1, right, of the function x squared plus 2. Okay. So then we integrate. And then we plug in the values. So I'm getting 7/3 for the area under the curve. And to finish it off, area shaded equals the big area, as Sandra suggested, 3 times 1, the area of the rectangle, minus the area under the curve, and that gives us 2/3. How do we know the area of what? I'm sorry? Yes, the area of the shaded region will be the area of the big rectangle minus the area of... Yeah, oh yeah, 3 is the length times base, length times height. The length times width. The width is 1, the height is 3, so we multiplied. Right, because this distance was 1 unit, right? And this distance was 3 units. So we multiplied the 2 dimensions to find the area of the rectangle. And remember, if I did not give you the number 3, you should be able to determine that yourself. And how do you determine it? By plugging 1 into the function, right? Okay. Now a few examples on practicing problems with definite integrals. In other words, these questions, they're not asking you to find the area. These are just practice problems on evaluating what is called definite integral, meaning an integral that where you have limits of integration, like you're going from 0 to pi or any number of values given. If the question does not say find the area, you do not have to graph it. And the answer can be negative, we don't care. The only time we care is if the question says find the area, okay? Otherwise, it's just a practice problem on the integration process. So the first one is asking, what is the integral of 1 plus cosine x dx from 0 to pi? So what is the antiderivative of 1? Of course, that's x. Antiderivative of cosine x is positive sine x, right? In their differentiation, it was negative. In anti-differentiation, it is positive, and we're going to go from 0 to pi. And of course, plug in the limits. First, the upper limit minus the lower limit. Okay, what do we know about sine of pi? So sine of pi is 0, right? Because sine is 1 up here, negative 1 down here. It's 0 here and here, right? So sine of pi is 0. So we're going to get pi plus 0. And sine of 0 is 0 as well. So everything else disappears. So the answer is just pi. What about the next one? The integral of 4 secant u times tangent u. First things first, the antiderivative. It's just secant, right? But there's a 4, so it's going to be 4 times secant of u. How do I know this? Because the derivative of secant was secant times tangent, right? So the antiderivative of secant tangent is secant. And the limits are from 0 to pi over 3. Now, when you have a constant, you can factor it outside if you like. And you can write it like this. 4 times secant of pi over 3 minus secant of 0. Now, pi over 3 is 60 degrees. What is cosine of 60 degrees, first of all? Cosine 60 is the same as sine 30, which is 1/2. So secant of 60 degrees will be 2. So here we're going to have 4 times 2 minus, what about cosine of 0? Cosine of 0 is 1, so secant of 0 is 1 as well. So we're going to have 4 times 1. In other words, the answer will be 4. Okay, one more. Okay, the integral of secant squared t dt, 3 times secant squared from 0 to pi over 4. Once again, what is the antiderivative of this function? Again, think of a function whose derivative is secant squared, right? Which is the tangent, exactly, the tangent function. And we're going to go from 0 to pi over 4. Pi over 4 is 45 degrees. What do we know about tangent of 45 degrees? That's 1. And tangent of 0 is 0. So the answer will be 3 times 1, or 3. Okay, I'm going to give you one more. Okay, let's do this one. Find the integral of from 1 to 4 of negative x squared plus 2x minus root x plus 1 dx. It's going to be a little bit messy. And let's see what you're getting there. Okay, so I took my antiderivative, I plug upper limit minus lower limit, and again, I'm going to collect my whole numbers together and then the fractions, and then at the end combine them all together. So I'm going to combine 16 plus 4, which is 20, minus 2, which is 18. And then the fractions, I've got negative 64 thirds, minus 16 thirds, and then, pardon me? Yes, how do we integrate root x? Yes, root x is the same as x to the 1/2. Right, right. But I'm going to show it down here because I have more room down here. Right. So root x is the same as x to the 1/2, right? Its antiderivative is we add 1 to the power, gives us x to the 3/2, and we divide by that power. Dividing by 3/2 is the same as multiplying by 2/3. So that's how we got that term. So when I was combining my numbers on the bottom, I took the whole numbers first, and then the fractions. Now this gave me 3/3 or 1. So I'm going to combine it with my whole number, 18 plus 1 will be 19. Oh, did I miss that? No, no, no. The 18, look at my red check marks. I had 16 plus 4 was 20, and minus 2 was 18. That's how I got my 18. Again, there are many, many ways to do this. You know, maybe you do everything in the first parentheses first, if you prefer. Do everything in the second parentheses, and then just do one subtraction. Obviously, you can use a calculator if you want to. You can also do that. So again, do it any way that is more convenient for you. So now I'm combining negative 64 minus 16. That's going to be negative 80 thirds. And then finally, I get common denominators here, 3/3. And that's going to be 57 minus 80/3. So that's like 23 thirds, but it's negative. How many of you, again, no matter which way you selected, how many of you got the same answer? Good, and some of you are still working on it, which is perfectly fine. As you can see, it can get a little bit messy, and you just do lots of practice to get all the the little details out of your all the possible places you can make mistakes. The biggest problem usually is this negative sign right here. Make sure you distribute that negative sign very carefully to all the terms after it, or like I said earlier, do everything in one parentheses, do everything in the other, and simply combine them with one subtraction, of course, by using the calculator. And let me end today's lesson by showing you a nice shortcut method on the calculator, a way you can check your answers. But obviously, since I'm showing you this, I'm going to want to see all the work, but you can check your answers this way. There is a function integration key in your calculator. It's under the math menu. So go to math and go all the way down to find the function integration key. So go to math. You can go all the way down or go up where it says FNINT. It's number 9 on my calculator, as you can see, FNINT, function integration. And the commands it takes are the function you're integrating. Let's do something really simple, like the x squared function, right? So just put the function you're integrating. So you're integrating x squared, comma the variable x, comma the limits from where to where you're going. Let's say we're going from 0 to 1. And what do we get this answer to be? We can do this in our head now, right? What is the antiderivative of x squared? X cubed over 3 from 0 to 1. The answer should be what? 1/3, right? Let's see. Press enter. There we have it. It gives you a numerical format instead of the fraction format. But again, it's a great way to check your answer. Go back if you didn't get the same answer by hand. Debug your solution, find where you made that mistake. But obviously, I'm going to need to see every single work. Now I'm even more careful so to check the work because I know the calculator can give you the final answer there.